Good morning, good afternoon, or good evening. This is going to be a full paper work through of the second mock paper used in January 24. The aim of this is twofold. One, to give you an idea of the kind of thought processes, the useful ideas and concepts to be thinking about when you're doing a mock like this, in particular in relation to exam technique, and also to have a resource to aid your own self-reflection from the mock itself, to aid you filling in the gaps and making those improvements yourself. As always, at the beginning of every paper, make sure that you've got all of the equipment that you need to hand. I've got my graphical calculator and I've also got the formula book to hand just in case I need either of those things. We'll pick our name for the day. We'll go with Mr. Scheme, first name Mark, as our amusing name for this paper. So we'll jump straight in. This is mostly a blind work through of the paper. I have most likely seen these questions before and will remember some of them, but hopefully most of this will be first reactions to a lot of these questions. Our first multiple choice question, we have a graph of y equals f of x. Straight away, without looking at the choices, my mind went to this is a modulus function. We have this type of V shape. The V shape is very classic behavior of the mod function. So, and straight away looking at the answers, it is indeed. Now, the important point about the mod function is always this bottom point here. That's when the modulus sign is actually 0. So this looks like the modulus is 0 at a positive value of x. But if I look at the first two, those modulus signs are 0 at x is negative 2, so it can't be either of those. So it has to be one of the second two just by looking at the x thing. Well then, if I do sub in that special x value, which we now must be 2, if I sub that in, well, this one's going to tell me that y is 3, whereas the bottom one tells me that y is negative 3. Well, clearly from the picture, it's at a negative y value, so it has to be the bottom one. Another way to tackle that question is to think about transformations. This looks like your normal y equals mod x, but translated by 2 negative 3. And if you think about what a translation by 2 negative 3 does to the function, you do indeed get the same answer. Question 2. Express that piece of algebra in that form. Okay, so we need to simplify, we need to divide through by the x squared. The 5 divided by x squared, or dividing is a negative power, so it's 5 to the negative 2. I am also going to rewrite the cube root as a power just to aid me. And again, subtracting the powers, it's going to be subtract x to the power of a third minus 2, negative 5/3. The question didn't tell us to state the values, but you can if you wish. But that first line there would have gained you the marks. Question 3. A curve has that equation. We want to find the gradient at the point where y equals 10. Okay, that's a bit sneaky. Sneaky because normally we expect the x value to be subbed in. Let's see how that matters in a moment. Firstly, gradient tells me I need to dy by dx. Differentiating that is sort of kind of a chain rule-esque question. E to the 2x looks like e to the 2x on differentiation, but a 2 pops down, timesing the 3 in front. So at y equals 10, but exactly as I've said, that doesn't have a y in, so we need to find the x value. And already I'm seeing a sneaky trick we can do here. At y equals 10, that's equal to the 3 to the 2x. How sneaky do we want to be? Let's be a little bit sneaky, not go full sneak. If I divide through by 3, I get e to the 2x. Now, it is tempting to continue to solve this. To find the value of x, take logs, divide by 2, but we don't need to. Because the dy by dx has that e to the 2x in it. I don't care what x is if I know what e to the 2x is. So I'm going to replace the e to the 2x rather than doing extra work to then undo that extra work. 6 times 10/3 is 20, and that is my gradient. There were, as I kind of hinted at there are more sneaky tricks to do even less work. But of course, the sneakier the trick, the more work it takes to think about them. Question 4, sketch that curve. Well, that's cubic, is going to have a repeated root at 0. We know that a is positive, so the other root is at negative a over 2, which is a negative because a is positive. So this is a cubic start bottom left. We know it has a negative root, we know it has a repeated root at 0. So we've got a repeated root at 0, and I'm going to label the other root on. There's no y-intercept to label because we have a root at the origin. We have a new polynomial. It's given that x plus 3 is a factor. Use the factor theorem to show that a equals 2. Well, factor theorem says that a root gives you an equation that p of negative 3 equals 0. So let's solve that equation. Subbing in negative 3, that's going to be 9 lots of a minus 6. I've subbed in the negative 3 onto the left-hand side. Plus 36 equals 0. So 9a minus 6 equals negative 36. It is a show that question, so I should have done this step here a little bit slower. I'm not going to expand the bracket. I'm going to divide by the 9 and then add the 6. And we get the a equals 2 as required. Now, I'm not worried too much about that extra step in there because it was only worth 2 marks. Okay. State the transformation which turns that curve into that curve. Well, there's only a slight change. The only thing that's changed is we've added 36 on the end. And from all of those transformation facts that we had to memorize, this is a translation by 0.36, up by 36. The polynomial can be written as that without finding the values of b, so use your answer to a and b double I to explain why that. Okay, well, I could find that extra quadratic. That won't be too difficult. It will involve expanding out and then refactorizing. But this thing looks a little bit familiar. This looks like the discriminant. We have a b squared, a multiple of 4c. And if you think again, it is exactly the discriminant of that quadratic. So we need to refer to part A and B. A was that picture, and B double I, was the fact that we translated upwards. So let's put those together. So the curve y equals x squared, 2x plus 2 plus 36, has exactly one root, as part A showed one root and a repeated on translation by 0.36. I'm now including the b double I part. The repeated root is removed. So I've excessively explained why this curve has one root, which is going to imply that the 2x squared plus bx plus c factor has no roots, because I already have a root from the x plus 3 bracket. So now going back to the other form of this cubic. And if you've got no roots, that means your discriminant is negative. I've used way more lines than I really needed to. Minus 4 lots of 2 lots of c is negative. B squared minus 8c is negative. Or b squared is less than 8c. I didn't use the whole lines. I did use a little extra space. But I did justify the single root in a bit more detail than I maybe needed to. Question 5. A new design for a company logo is made from 2 sectors of a circle and a rhombus as shown. POQ lie on a straight line. That angle there is theta radians, or straight away I'm not sure if I'm going to need it. Well, I'm almost surely going to need it, but I'm going to fill it in here anyway. That whole angle POQ is going to be pi radians. I was told that we were in radians. Subtract off the theta and divide by 2. Each of these are going to be pi by 2 minus theta by 2 radians. So that's going to come in helpful. A large copy with PQ being 5 is going to be put on the wall. Show that the area is given by that thing. Okay, so one thing to notice is the radius is 2.5. The area of a rhombus, lots of ways to think about it. One, to think of it as parallelogram, do base times height, but I don't really have the height here. Instead, I'm going to split it in half and do 2 lots of the area of a triangle. So let's start building this up. So the area of, let's go with ORS, is half AB sine C, which is a half of 2.5 times 2.5, half of 2.5 squared times sine theta. So that's going to be 2.5 squared is 5 over 2 squared is 25 over 4 is 25 over 8 with the half sine theta. So the area of TRS is also going to be the same. So the area of the rhombus, which is ORTS, is 2 lots of the ORS area. So that's 25 over 4 sine theta. So that's the rhombus done. Now let's do the 2 sectors. And again, there's lots of ways to cheat. I'm going to put the 2 sectors together. So I'm going to have the area of a sector is a half theta r squared. Well, the angle that I have, if I put those 2 angles together, so I've got an angle there and an angle there. I put those 2 pizza slices together. I'm going to have a total angle of pi minus theta times by the radius squared, which again is a 2.5 squared. So that's going to be 25 over 8 again, pi minus theta. So the total area, 25 over 8 pi minus theta plus 25 over 4 sine theta. The final step of simplification, noticing that if I factor out the 25 by 8, I'm going to have 2 sine theta, not just sine theta. This already is screaming at me an optimization question. Step 1 of every optimization question is to write A in terms of 1 letter only. And that's what I managed to do there. A is in terms of theta. Part B. Show the maximum value occurs when theta is pi by 3. Maximum is implying that the first derivative equals 0. So I'm going to try and solve dA by d theta equals 0. So I'm differentiating that a thing. So I'm going to brave and try and do it over the 2 pages. You've got the 25 pi 8 multiplying factor is not going to change. The pi differentiates to nothing. The minus theta differentiates to minus 1. And the 2 sine theta is differentiating to 2 cos theta. Okay, well then I'm going to tell the examiner what I'm thinking. The maximum is going to imply the dy by... I went straight away for dy by dx, but dA by d theta equals 0. So that's telling us that minus 1 plus 2 cos theta equals 0. The 25 by 8 can just be multiplied into the 0 or divided into the 0 to disappear entirely. So therefore cos theta equals a half. Doing the inverse of a half, that is one of your exact angles. So you might be able to do this one in your head straight away. I'm always going to check on the calculator if I have the calculator available. Is pi by 3. I'm thinking about trig. Trig always says there's multiple solutions. So 0 to 2 pi. My second solution is 5 pi by 3. Thinking about the context of the question. Were we told theta was acute? Not explicitly, but 5 pi by 3 answer. Well, that's not even obtuse, that's reflex, so that's way too big. So that's out of a reasonable range. So we have our pi by 3. We have shown that there is a stationary point at pi by 3. We haven't shown that it is a maximum. So I still need to justify that it is a maximum. So I take my second derivative. Differentiate again, the 25 by 8 is still going to just live as a multiplying factor. That's going to differentiate into 2 sine theta inside the bracket. So at theta is pi by 3. The second derivative is going to be simplified just a tad, bring that 2 out, of pi by 3. That is an exact angle. That's the one that has a root 3 involved. I'm still going to type it into my calculator. So negative 25 by 4 sine of pi by 3. So that's negative 25 root 3 over 8. The important thing is that is negative, which implies that the theta's pi by 3 is a maximum. Double check that I've done everything correctly. I've checked it's a stationary point. That's telling me that this pi by 3 is a stationary point, and then I've checked it's the right type of stationary point. So yes, I have shown, and my conclusion over there is sufficient, is sufficiently supported to say that pi by 3 is a maximum. The question continues, finds the exact maximum value of A. So this is asking us to go all the way back to what A was in the first place. Now I'm going to trust my memory and then check it anyway. I believe that's what A was, 25 by 8 pi minus theta plus 2 sine theta. Yep. So at that value of pi by 3, now it is really tempting to type all that into your calculator. However, it does say exact, which is telling you don't, because your calculator is unlikely to keep it exact all the way. So you have to do a little bit by hand. Pi minus pi by 3. I'm going to make sure that I write it so it's not ambiguous. Now sine of pi by 3 was the root 3 over 2. And the extra 2 in front means that's just plus root 3. I'm debating with myself how much I want to expand or indeed refactorize. My instinct is telling me to factorize out the third and then to stop there, but any correct form will be credited. If you expand your brackets out, you'll be credited. If you left it in that line, you should still be credited. Without further calculation, state how your answers to part BI and BII would change if PQ were increased to 10 meters. So if we go all the way back to the start, instead of this length here being 5, we're now going to say it's 10. So we've made the whole picture twice as big. Now if we just make the picture twice as big, well, thinking about similarity, that's going to multiply my area by 4, the 2 squared. That's not going to change anything to do with theta itself, because if the area is 4 times as big, and then when I when I try and solve this first derivative, 4 times bigger means nothing. That 4 can be divided into the 0. So my theta is unchanged. Second derivative, again, is not going to be changed. The second derivative will be 4 times bigger, but that doesn't change whether it's positive or negative. So theta will be unchanged at pi by 3, but the maximum area, let's double check that is what it's asking, without further calculations, to BI and BII. BII was to find the maximum area, but the maximum area of A will be 4 times larger. If I scale up the whole picture by 2, the area gets 4 times as large. State how they will be changed. I don't need to recalculate the new A. It just says state how they will change. I've told you how they would change. Question 6. Use that given substitution. Oh, and this is nice. This is probably my favorite type of substitution. There's a little bit of sneaky that happens. So use the substitution u equals x to the 5 plus 2. Just smashing our head into the method, we differentiate, and we're trying to rewrite to make dx. And I put these little quotations around because you're not really supposed to separate a du by dx thing, but it just helps you visualize what's going on. So now I'm going to call that I just so I can say I equals is now going to equal the integral of x to the 9 over u cubed times the 1 over 5x to the 4 du. Now I did notice the original question had limits, so I do also need to deal with the limits at this point. As soon as I write du, I need to have u limits. So when x equals 1, u equals 1 to the 5 plus 2. When x equals 0, 0 to the 5 plus 2. So now I have limits between 2 and 3. There's a little bit of simplification to do here. I'm going to factor out the number, the fifth. I'm going to cancel a bit. And at this point, I'm a little bit sad. The whole point of substitution was to change all of the letters from x into u. I still have an x to the 5 on the numerator, but that's not too much of a problem once I remember that x to the 5 plus 2 was u, so x to the 5 is u minus 2 du. To put this into an integratable format, let's do the division and write them as negative powers. So I'm going to divide both of them by u cubed, as so. Now I can finally do the integration. Being the show that, of course, we could have put this into our calculator on the first step, but that wouldn't have got us any credit whatsoever. Increase the power by 1, divide by the new power. I should be using square brackets now. Increase the power, divide by the new power, increases the power to negative 2, divided by negative 2. And actually the integral turned out incredibly pleasantly, which I shouldn't be surprised because the answer we're aiming for, 1 over 180, is a really pleasant answer. Subbing in, so that's a fifth. I'm going to go back to fractions at this point, so that's negative a third plus a ninth. Subtract negative a half plus a quarter. And you can now start to argue, how much do I do in my head? How much do I try and continue to do by hand? I like fraction work. I'm going to do it by hand. So that's going to be 3/9, negative 3/9 plus a ninth. And then we're subtracting negative a half plus a quarter is a half. And I'm getting happier and happier at every stage because I'm starting to see, or am I actually? Mistake has been made. So how did I spot a mistake? I'm seeing the common denominator here of 18, but 18 times 5 does not give me the denominator of 180 that I wanted. So I immediately knew something had gone wrong, and in my speed, negative a half plus a quarter is negative a quarter, so that's going to be plus a quarter. So you're going to get over 36 instead. So that's going to be negative 8 plus 9 with my common denominator. That's a fifth times 1 over 36, which is indeed 1 over 180 as required. And I'm happy. That last bit of simplification you probably could simplify that a bit with your calculator work rather than going back to by hand fractions. But everything else I did show very carefully for the show that question. Question 7. Points P and Q have those coordinates respectively. Find the coordinates of the midpoint. Midpoint's quite nice. Midpoint's just the average of the two coordinates. I can see it's only 1 mark. So it's going to be negative 6 plus a 12 over 2 and 15 plus 19 over 2. That's going to be 3, 17. Find the equation of the perpendicular bisector. Well, that's quite nice because bisector means we go through the midpoint, and I've just worked out the midpoint. I still need to find the gradient, so let's try and find the gradient of PQ. Gradient is change in y over change in x. Now, I did intend that to be negative on the denominator, but it didn't pick it up. 12 minus 6. Make sure I've got everything right. I've done the second minus the first over the second minus the first. That's good enough. That's 4 over 18 or 2/9. So the perpendicular gradient is the negative reciprocal, negative 9 over 2, and we know it's going through 317. So our favourite formula, y minus y1 equals mx minus x1. My habit on all of these is to multiply up the denominator. I know I'm aiming for a form where they're all integers anyway, so instead of expanding the bracket out with a fraction, I'm going to cheat and multiply up straight away. So that's 2y minus 34 equals negative x plus 27. Be careful with your signs there. We wanted x and y on the same side, so add on the 9x, add on the 34, is that 61? It's quite a big number. A little check that I can do is to sub in the midpoint and check whether that works. So in my calculator, I'm going to do the 9 times 3 plus 2 times 17, and it does give me the 61. So I did do that part. At least that little part of the working correct. Of course, if I was checking more thoroughly, I would also check the gradient calculations. Continuing question 7. A circle passes through P and Q. The center of the circle lies on the line with that equation. Okay, so we have, and at this point, I want to visualize this a bit better. We have that the center of the circle lies on 2x minus 5y equals negative 30. Now, there's no reason why P and Q... Okay, memory is coming back now. So we have another line that goes through P and Q, and this is where a circle theorem comes in. The perpendicular bisector of the chord goes through the center. The perpendicular bisector of any chord goes through the center. So the center of this circle is on 2x minus 5y equals negative 30, and from the previous bit of working, 9 to 61, 9x plus 2y equals 61. So we have a point which is on two lines at the same time. Well, that's simultaneous equations. So let's do it. So the simultaneous solver on our calculator is going to guess the answer to that very quickly. Simultaneous, two variables. My coefficients are 2, negative 5, negative 30, and 9 to 61. That gives me my x value as 5, and my y value as 8. So that's my centre. The centre of my circle is 5, 8. Now I still need the radius. I'm aiming for the equation of the circle, so I still need the radius. I'm going to remind myself what the point P was, negative 6, 15. And therefore the radius is just the length of P to the centre. So the modulus of PC is the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared, all square rooted. So that's going to be the square root of, is that 160? 11 squared plus 7 squared is 170. And therefore the equation of the circle is x minus the x coordinate of the centre squared plus y minus the y coordinate of the centre squared equals the radius squared. And that's done. One thing I would like to do before I move on to the next part of this question, as another one of those little mental checks, is to check if Q works. 12, 19. So this I can do as a mental check. I'm going to type into my calculator, well, 12 minus 5 is 7 squared. 19 minus 8 is 11 squared. Oh, that's exactly the same number as the other way round. Does give me the 170. So both P and Q do indeed lie on this circle. And the centre we got from the calculator. We couldn't have really made a mistake there without typoing. The circle intersects the coordinate axis at n points. Okay. Well, that's a bit interesting. Two ways to do this question. I'm going to do it one way and then I'll tell you the hint. One way is to have a quick sketch. So there's my 5, 8. Root 170 is 13, just over 13. So 5, 8, well, it's definitely going to cross. Actually, how far is 5, 8 away from the origin? 5 squared plus 8 squared. It's definitely smaller than 170. So my circle is definitely going past the origin over there. Well, most importantly, if that part there is 8, the radius is 13, it has to go below the axis. That coordinate there is 5. The radius of 13 goes further than the x-axis. So n intersects in 4 places. Alternatively, you could just sketch the circle in your calculator. The difficulty being circles you can't do in the graph setting. You have to use the conic section. Scroll down till you find the one that looks like the circle equation. And you just put the right values in the right places. So you still can draw circles in your calculator, it's just in a slightly different position. That was question 7 done. Question 8. We have the sine curve in degrees. Point A is 0, a half. Well, that's saying that sine of A equals a half. If I just sine inverse that, I'm going to be a little disappointed because it's not going to be correct. That gives you pi by 6. So I either need to change my calculator into degrees, which I'm definitely going to regret later, or convert in my head. I'm going to turn it into degrees. So that would say A is 30, but that's not where it is. The 30 is the solution here. Didn't want that one. 180 minus it gives you the answer here. Don't want that one. The 150 was a good idea because I can just go all the way back here by minusing 360. So, and of course there's more possibilities. The one that matches the picture is A is negative 210. State the value of sine of 180 minus that A. Well, that would be sine of 390, which is the same as sine of 30 by subtracting off 360. Well, that's the same again. That's going to be a half again. And you could have used the symmetry. This 180 minus A is the go-to for converting sine angles. So it's exactly the same output. Point B. Oh, now they're being sneaky with it. Okay. So find the exact value of B, of sine of B minus 180. Again, I'm thinking there are multiple ways to do this question. The first thing that we know is sine of B is equal to negative 7 over 3. So negative 7 over 3, let's get rid of a little bit of the annotations, is going to be down here. Now, it didn't tell us anything about B. So B could be any of these points here. Oh, no, it's not. It's on the picture. I'm just blind. There is a B already on the picture right there. So that is my B. If I do B minus 180, or whatever that value is, subtracting 180 is going to come up over here. It's just, well, it's just over where the origin is. Now, a couple of things which you should have intuition of. If you're adding or subtracting 180, doing 180 minus, 360 minus, that maintains the kind of the symmetry of the picture. And indeed here, the symmetry is maintained, but it's swapped sign. So actually, this is as simple as swapping the sign. So this is just positive 7/3, which is sneaky for 2 marks when you can just write down the answer. The alternative, which is what I expect the examiner will be expecting of the majority of students, is to expand it out with the double angle formulas. And I've already quoted that wrong. So the double angle formulas say this. Sine of the A minus B is sine cos minus sine cos. However, cos 180 is not 0. Is 0? Cos of 180 is negative 1. There you go, I'm getting the curve in my head right. And sine 180 is 0. So, oops, that's going to come out as negative sine B, which is positive 3/7. A little bit sneaky there, just a little bit sneaky. Find the exact value of cos B. I should actually say both those answers give the exact same working. You can either hit it with the formula, do more work, or do more thinking. You're either doing more work or more thinking, so it is fair to give that 2 marks in both situations. Exact value of cos B. So I like this trick a lot. I'm going to ignore the sign for now and just try and find the size of cos B. Sine B is, sine is the opposite over the hypotenuse. I could put B in a triangle as so. I could use a bit of Pythagoras. B squared minus A squared plus B squared equals C squared. So 49 squared is 9 squared plus that side squared, subtract off the 9 squared. That side there is root 40. So cos of B is going to be either plus or minus the adjacent over the hypotenuse I do know I can simplify the root 40, and I'll do that in a moment, but I want to justify the plus or the minus sign. And again, I'm going back to the graph over here. What is the sign of cos? Well, I've got the sine curve drawn. Let's draw on the cos curve very roughly as well. And you'll notice that B here, well, it's giving you roughly what that value is. And if you do work it out, that cos value will be more negative than negative 3/7. But the point is it's negative. That B as is placed is going to be the negative solution. And I'm also going to simplify that third on the top at the same time. Put a little comment, we're going to choose a negative sign as cos theta is negative for, and the important bit here is we're between 180 and 270 for that B, because that's where it is in the picture. 3 marks there. Again, not a huge amount of working, but a lot of thinking. Question 9. We want to differentiate 2 to the x. Now notice the way it's worded. Write down. And it's only worth 1 mark. So that's just telling you, don't tell me why, just do it. And hopefully you now remember that the derivative of something to the power of x is ln something times the something to the x. Hence find, well, the first part of the question is telling you that that ln 2 times 2 to the x integrates to 2 to the x plus c. But I didn't want this ln 2. So I want to somehow remove that ln 2. And the trick that we've always done is to put it in but divide by it. So the integral of 2 to the x is the integral of ln 2 times 2 to the x. But I cancel the ln 2 back out, so my answer is 1 over ln 2 times 2 to the x plus c. That's only part A of the question. Let's see how it develops further. The area bounded by 2 to the x. Okay, well that's why I've been integrating it. The x-axis and the y-axis and the line x equals -4 is approximated with rectangles. Show the exact area of the largest rectangle. Okay, so one thing I really would like to know is what are all of these x ordinates? How many are there? Do I have to count them? No, they said there's 8. So I've got 8 ordinates from 0 to 4. So that means I'm going up in halves, or down in halves if you'd prefer. I'm going to label them on just because I might need them again later. So I want to show that this rectangle here has the area of root 2 over 4. Well, that rectangle has a base of a half, and the height of that rectangle is if I sub that half, that negative a half ordinate, into the y thing. So it's going to be 2 to the power of negative a half. Well, now it's just simplification. That's a half times 1 over root 2. 1 over root 2 rationalizes to root 2 over 2 is root 2 over 4 as required. Again, because it was a show that I've forced myself to do every piece of working very explicitly. I can check each step with my calculator, but I want to show the examiner I've made all those steps. The question continues. The areas of these rectangles form a geometric sequence, oh that's very nice, with a common ratio. Find the exact value of the total area of the 8 rectangles. Okay, well one thing to notice is that root 2 over 2 is roughly 0.7, so this is the ratio as our rectangles are getting smaller. We had the first rectangles was root 2 over 4. The common ratio is root 2 over 2. We want the exact value of the 8 rectangles, so we want the sum, not to infinity as I was about to write. We want the sum of the first 8. which is the formula. So that's going to be, now it wants exact value. So I'm really tempted to type this into my calculator, but I know that's going to fail me. So instead, I've got 8 on the brain. Instead, I'm going to write it out and try and simplify as much as possible without the calculator. First thing to try and simplify is that root 2 over 2 to the power of 8. If I do want to trick my brain a little bit, I can unrationalize the root 2 over 2. So 1 over root 2 to the power of 8 is 1 over 2 to the 4 is 1 over 16. So that's root 2 over 4 times 1 minus 16. And by the amount I'm writing, you could probably trick quite a lot of this in your calculator. And now I am actually going to check that top bracket in my calculator, because I don't necessarily trust it all of the time. So that was root 2 over 2 to the power of 8 does indeed come out with the 1 minus coming out as 15 over 16. So I need to keep simplifying. The thing I hate the most right now is the fractions. So I want to get rid of all of those fractions at the same time. I'm going to multiply by 64 over 64, because that's how to get rid of those top fractions. Doing that, my numerator is simple, and my denominator times in that by 64. I'm going to put a 32 on the outside and write it like that. So I've times the bottom by 2 really, and kept the rest of the 64, the factor of 32, out of the way. And I'm doing that because I know I need to rationalize this. Now I am noticing it is only 3 marks, so to do it, the full rationalization by hand is excessive. I'm going to do it anyway, but it is excessive. So the top's going to become 30 root 2 plus 30 over 32. 2 minus root 2 times 2 plus root 2. We're going to have 4. The middle terms cancel, minus 2. I'm going to factor out the 30 on the top because I know my answer wants that to happen. 64. And then finally, in the form that the answer wants, a constant in front, 1 plus root 2 in the bracket. My k is 15 over 32. Oh, that was a lot of effort. Now, it's worth not forgetting why we were doing that. That was the total area of all of these things. We might be saying something about an approximation next, so let's see. More accurate approximations for A can be found by increasing the number of rectangles used. Find the exact value of the limit of the approximations as n tends to infinity. So that's really sneaky. If I put more and more rectangles in, you'll notice, and I'm kind of splitting these into more and more rectangles, you'll notice the area of the rectangles, the total area of the rectangles, will tend towards the total area under this curve. So as we tend to infinite number of rectangles, the area under the area of the rectangles is going to be exactly the area under the curve. So find the exact limit of the approximation so that sum of rectangles is going to tend towards the integral between 0 and negative 4 of 2 to the x dx. And now part A of the question is coming into fruition because we integrated that in the first part of the question. Not over ln x over 1 over ln 2 to the x between the limits of 0 and negative 4. Sub in those limits, that's going to be 1 over ln 2, or 2 to the power of 0 is just 1. Subtract 1 over ln 2, 2 to the negative 4 is 1 over 16. and with a little bit of simplification. And we can't really cheat in our calculators. The way I've managed to do that is think about factoring out the 1 over ln 2. So really I've got 1 minus a 16th. And then the 1 over ln 2 just sits on the denominator. Okay. And again, because we've got such fancy calculators, I'm actually going to do this integral in my calculator. You could potentially even do it in the graph mode. You can find areas in the graph mode as well, between the limits of -4 and 0. Now that's giving me an answer of 1.35 nonsense. I'm also going to write in what I think the answer is exactly, and I'm crossing my fingers and hoping, and it is exactly the same. So that's another really good check. Have you done something correctly, or use the resources available to you, in this case the strength of your calculators, to make that check for you. Question 10. Oh, that's a very nice looking curve. It's a implicit. You can't get shapes like that if you're not an implicit curve. And it has a single stationary point at P. Show that the y coordinate satisfies that equation. Hey, stationary point says the first derivative is equal to 0, so I have to try and differentiate. So let's try and diff with respect to x. Now I can't write dy by dx equals implicit, not allowed to do that, so that's why I've written it out in full with the colon instead of an equals. Differentiating it, x squared differentiates to 2x. 2y cubed is going to differentiate to 6y squared, because it was a y thing and I'm differentiating with respect to x. I need the dy by dx correction term. And then finally the last term is going to be a product rule. We've got -4x times by the derivative of y, or we have the y times the derivative of -4x equals 0. Now it is tempting, and I'm going to cheat again, I like simplifying my working as much as possible. It is tempting to rearrange this to make it dy by dx equals. You don't need to. Unless the question tells you to find the derivative, you don't need to. So at a stationary point, dy by dx equals 0, which means that this equation simplifies quite drastically. Both of the 6y squared dy by dx and the -4x dy by dx both become 0, disappear entirely. So that's telling me that x is equal to 2y. Well, the trick now is to sub back into the original. Sub into original. My x and y coordinates have to satisfy both the original and this new thing. So subbing it in, the x squared is going to become 4y squared plus 2y cubed minus 4 lots of this 2y times by y, that's minus 8y squared equals 0. That's 2y cubed minus 4y squared equals 0. I'm going to divide through by 2. Again, I'm doing an excessive number of lines of working for this, but it is a show that, so that's how I trained myself to work on these questions. And I've got exactly what the question wanted. 7 marks for that. Yeah, we've done a lot of work for it. Hence, find the coordinates of P. Okay, so we need to solve that first, and then we need to go find the x value. So we have y squared, y minus 2 equals 0 is going to imply that y equals 0 or y equals 2. Remember that x was equal to 2y. So we got those possibilities. That's awkward, because the question doesn't say find the possible values of the coordinates of P. It says find the coordinates of P. There's only one coordinate of P. From the picture, it's obvious it's not the origin. The origin is a bit of a weird position. You can see the curve goes through the origin twice. Another feature of implicit curves rather than the normal y equals. So I'm just going to reject that one. That's not my stationary point. I've only got 2 marks here. I'm not going to expect the examiner wants me to go into detail on why I projected it. And then I'm going to quote P in the correct order. Although we found Y first, we still need to put that X coordinate first. Is it obvious why 0, 0 fails? Why 0, 0 is a solution, but is not necessarily a stationary point? It certainly doesn't look like a stationary point either time it goes through. Kind of looks like the gradient is infinite on that branch as I go through 0, which of course is very awkward because that would mean oh, I can see it then. Yeah, so if I was to rearrange this thing, the 6y squared minus 4x would be 0 at 0, 0. We were dividing by 0, so my gradient isn't 0. It's some nonsense. Whenever you divide by 0, a lot of bad things happen. So if I did actually do my rearrangement of dy by dx equals, it would have been a bit more obvious why I had to reject the 0, 0 coordinate. But the picture told us that it wasn't the origin, so we could just write it down. Okay, we are now on to the stats section. So, question 11. Which of the following sampling methods does every member of the population have an equal chance of being selected? Well, the equal chance is exactly the feature of the simple random sampling. Quota is a no, because you just stand on a corner and ask the first people who walk past. If they don't walk past you, they've got no chance. Convenience is just the first people that walk past. Again, if you don't walk past the surveyor at the time, you don't get chosen. You've got no chance. Cluster feels like it's less obvious why it fails. Does every member of the population have equal chance? So the weird thing about cluster is not every sample is equally likely to be chosen. Cluster must have some kind of convenience quota essence into it, which I'm misremembering at this point. But simple random is clearly satisfies that condition. So we'll go with that as our answer. Question 12. A random sample of 10 students from a college was chosen. They were asked how much time they spent studying and how much money they earned in a typical week. Those are the results. Comment on the relationship during the times. It has a, I don't know if I can show you. Yeah, I'll say strong negative correlation. It's basically saying that most of the data is very well clumped towards a negative gradient line. Strong negative correlation with one apparent outlier. That looks like an outlier to me. It's nowhere near the rest of the data. The coordinates of the points are, find the mean and standard deviation of those data points. So this is testing, can you use the stats section of your calculator? And here I'm hoping I can. So I'm going to input the data very carefully, input all the x coordinates into my first column, and then I'll put the y coordinates in my second column. Good thing to check is you actually do have 10 data points each time, because you were told there were 10. You were told that there were 10 people. My second column is going in now. There's not much interesting things I can say about this question until the data's in. Okay, so I've got my data in and I'm going to do a calculation. It's a two variable calculation that I want. Oh, I didn't need to put all the data in, didn't I? I didn't read the question carefully enough. We only wanted the number of weeks studying, so I only actually needed the x coordinates for studying. So I didn't need to put all the data in. although I now have all the data, I can completely ignore anything that's related to Y and only read off the X things. So my X bar came out as 28.9, and my standard deviation, I should use little s, subscript X for the standard deviation, is 8.3. Doesn't tell me how to round it, so I'll go to 3 sig fig. 8.36. And I am going to look back at the graph. Does the mean of 29-ish look right? Yes. I've got about the same number of points on the left of that and the right of that. A standard deviation of 8 says that most of my data should be between that 29 subtract 8 and that 29 plus 8, which is there. I think it's exact. No, I think it's 66% of my data should be between those points. That looks about right as well. So these numbers look very reasonable for how my data looks. Only 2 marks, so quoting each value is all it's looking for. Mysteries from the future here, just to add an extra comment onto this question. So firstly, if we're looking at any context-driven question, really we should say these comments in context. So although you could argue this first part A getting both marks, really when we say negative correlation, let's actually say what that means. As the, and I need to remind myself of the context, as the amount of time spent studying, because that's the X, as the amount of time spent studying increases, and what was Y, the amount of money earned, decreases. So let's actually just put it in context for that section. And then the second part, in your calculator, you do actually have 2 options for standard deviation, sigma x and sx. Sx is if you are trying to use a sample to estimate the standard deviation of the entire population. Here we just want the standard deviation of this data, so we should be using sigma x instead of sx. I don't believe I still got the data in the calculator, but this was closer to 7 point something instead of the 8.36. So just a small mistake on my part there. That was it for question 12. Nice. Question 13. A histogram shows the length of centimetres of a sample of worms of a certain species. The number of worms in the section 3 to 4 is 30. Find how many are in 0 to 2. Issue here is we don't have that vertical scale. We do know that there are 30 worms in that section. Well, the base is 1, so the height has to be 30. So the height over here is 30 centimeters, or 30, no units. So now I need to be looking at this scale very carefully. If I put little dashes on every 5 is a good measure, and I'm hoping quite desperately, and here I've already lost count, just check my other ones, 1, 2, 3, 4, 5, no, that was only 4 I missed, 5, 1, 2, 3, 4, 5, perfect, and it does get there in the perfect number of 5s, so my scale is as simple as it could possibly be. It's just going up in 1s. So find number of worms in the length from 0 to 2. Well, that frequency is area, the base is 2, the height is 8. There are 16 worms in that section. Find an estimate for a number of worms from 4.5 to 5.5. So we're now looking at 4.5 to 5.5. So we're looking for the area of this compound rectangle. So the number of worms, the frequency is going to be roughly, the base there is a half. The 4.5 to 5 bar has a height of, this is what I'm trying to read it off the iPad, 24. But we also have the 5 to the 5.5 at a height of 12. So that's going to be roughly 18. Half of 24 plus half of 12. There's roughly 18 worms in that sample. Question 14. Probability distribution is given in the table. The one fact that we know about probability distributions is the total probability is equal to 1. So 1 is equal to the 3/8 plus 5 over 16 plus 5p. That's going to be 11 over 16 there. Subtract it off, 11 over 16 off from 1. And again, quite a nice number. P is 1 over 16. So then this will be a quarter, and this will be 1 out of 16. To check this, I am going to type into my calculator all these numbers and see if they add up to 1. If they do, good job. If they don't, I'm going to check my work very carefully. But these are the little checks that you can do relatively quickly and which are really, really promising for the results. So that was true. 2 values of x are chosen at random. Find the probability that the product is 0. Well, for the product to be 0, that means one of the 2 numbers had to be 0. The best way to do this, I'm really tempted to do a sample space. Yeah, I'm just going to do a sample space. So we have 2 choices of the values 0, 2, 4, 6, 0, 2, 4, 6. And I'm just going to fill in the probabilities in the middle to get 0 and 0. 3/8 and 3/8 is 9 over 16. The probability of 0 and then 2 is 3/8 and 5/16, which is 8 over 128. 8 times 16, 128. The next one is a quarter and 3 over 8, so it's 3 over 32. The 6 is the 16th and 3 over 8, 3 over 128. And just by symmetry of the situation, the ones down this column are exactly the same. I'm not going to fill in the rest because I don't care about the rest. The probability that the product is 0 is just going to be the sum of all of those probabilities. So now I just need to add them up carefully in my calculator. And again, I'm going to cheat a little bit and do 2 lots of the repeated ones. So I've got 9 over 16 plus 2 lots of the 8 over 128 plus 2 lots of the 3 over 32 plus 2 lots of the 3 over 128, and that's giving me a half. I'm pausing because that's awfully nice. And there wasn't enough symmetry in the question itself to imply that it should be that nice. Again, that'll be a question that I would come back to check at right at the end, check all of those calculations. There's nothing obvious, there's no reason why it can't be nice, but it is just a bit odd when you get a number that's a little too nice. Question 15. Probability that Janice sees a kingfisher on any particular day is 0.3. She notes the number of days in a week which she sees the kingfisher. State one necessary condition for x to be binomial. Well, our conditions on binomial, we can have to have a success or fail trial. Well, that's already obvious here. You either see a kingfisher or you don't see a kingfisher. The number of trials has to be constant. Well, the number of days in a week is always 7. That's constant. The last one is the important one. The probability or the, let's write it as the seeing a kingfisher on one day is independent. That's your key word that you're throwing in here. Is independent of seeing one on any other day. And that's the one which, if we think real life terms, isn't that likely to be independent. If you see a kingfisher on day 1, chances are those kingfishers are still in the area on day 2, so you're more likely to see one on day 2. If you don't see any on your first 4 days, unlikely to see one, less likely to see one on the next day after that. We're going to assume that x now has binomial, find the probability in a week we see it on exactly 2 days. First thing I always do is write down the distribution. So we're binomial, 7 days in a week, 0.3 chance. We want the probability that x is equal to 2, so I'm going to use BPD 2, 7, 0.3. This is where I desperately try and remember where the BPD is, and there it is. So 2, 7, 0.3 gives me an answer of 0.3176, etc. And quote my final answer to 3 sig fig. Each week, Janice notes. Before we move on from part 2, it's worth just having a think, is that a reasonable answer? One of the best checks to do is to work out the mean. The mean number of times that we see a kingfisher will be the n times the p is 2.1, which is telling us that the probability of exactly 2 should be the biggest of the probabilities, or 0.3 when you've got anywhere from 0 to 7. 0.3 is probably going to be the largest probability, so that does seem fair. Let's try and reread part 3 again. Each week we're going to note the number of days we see a kingfisher. Find the probability that Janice sees a kingfisher on exactly 2 days in a week, so that's my success criteria, in at least 4 of 6 chosen weeks. So now we've got 6 trials. Our trial is each week now, so we're actually doing the binomial of a binomial. So let's introduce a new variable. So let y be the number of weeks we see 2 kingfishers. So now y is going to be binomially distributed. Again, we're assuming independence here. We're doing this for 6 weeks, and the probability of success in this case is seeing 2 kingfishers, is 0.318. But the probability of exactly 2 days a week for at least. So we want to find the probability that y is at least 4 out of 6. So now I'm going to use the BCD function, and I'm going to go 4, 6, 6, 0.318, and that notation there is exactly saying we're less than or equal to 4. We're greater than or equal to 4, less than or equal to 6. You could do a 1 minus trick, which you had to do in the past with older calculators. These ones can do this thing, so I like to take advantage of that where I can. And that's 0.0856, etc. Again, I'm going to quote my answer to 3 sig fig as my final answer. Did we expect that to be incredibly low? Well, yes. The chance of this good thing happening is only about 1 in 3. So in 6 attempts, we should only succeed this in maybe 2 of those 6 weeks. We're trying to do it for at least 4 of the 6 weeks. So that does feel like it should be quite an unlikely situation, which that probability of 0.08 reflects. Question 16. It is known that 20% of plants of a certain type suffer from a fungal disease. and grown under normal conditions. Some of this plants are grown in a new method. Random sample of 250 of these plants is chosen, and it's found that 36 suffer. Test at the 2% significance level where there's evidence that the new method reduces the proportion of plants which suffer from the disease. Hypothesis testing, everyone's favourite. Step 1, let's write out our H0 and H1. So H0 is nothing has changed. So that's going to say the proportion is still going to be 20%. H1 is whatever we wanted has happened. We're trying to test whether it's reduced the proportion who suffer. So P is less than 0.2. I'm now going to define my variable. So let X be the number displaying the disease, and spelling is always difficult. Displaying the disease in the sample of 250. So I've defined X to be counting exactly the thing that we care about. So under H0, the X is going to have the distribution. Well, it's 250 samples, and H0 is telling me that the P is 0.2. So now, hypothesis testing, we've done all the setup now. We now want to calculate the probability of the sample, the thing actually happening, which was the 36, or more extreme. Well, with 250 and 0.2, that's got a mean of 50, so more extreme than 36 will be less than or equal to 36. We've also done that logically. If we're trying to reduce the proportion which suffer, more extreme would be even lower than that. So that's another BCD. This time it is a less than already, so I can just put in the inputs 36, then the N, then the P, and that's come out as 0.0138, etc. The significance level is 2%. This is smaller than 2%. So that's saying this event of getting this 36 was incredibly unlikely. So if it's incredibly unlikely, we're going to reject the model which led to this. We're going to reject H0. We assumed it at the beginning. Wasn't likely, so we're going to reject H0. There is sufficient evidence to suggest the new growing method, the new growing method reduces the proportion of the plants which suffer from the disease. And I did just take that bottom sentence there and write that sentence out again. It's always a good idea to use the words from the question. Is there evidence that the new method reduces the proportion of plants which suffer from the disease? Yes, there is sufficient evidence to suggest that the new method reduces the proportion of plants which suffer from the disease. And that's a full hypothesis question. Just having a glance through again, check I haven't missed anything. Mysteries from the future again, just to add an extra comment onto this question here. So the structure is fine. However, whenever you introduce a letter, you should be defining that letter. So I did define what X was here, but I did not define what P was. So I really should do that as well to guarantee that I get all the marks. So when I introduce P, let's say where P is, and this is the thing we're testing, so this is the proportion of plants which suffer from the fungal disease. So I just need to add that comment in. I've introduced this P, but I didn't tell the examiner what P was. So let's tell the examiner what P was. And that was the last question. So, as always, at this point in an exam or in a mock, or when you're doing these papers yourself at home in full, you would read through the whole paper again. You'll look for any gaps, fill in any gaps. But here we're going to stop. If you have noticed any errors that I have made at any point during this, please do let me know. I'll be happy to hear and make any corrections. Otherwise, I'll see you all in the future.